This is Mrs. Zappia with Lesson 8, Linear Equations in Disguise. Student outcomes for this lesson. Students rewrite and solve equations that are not obviously linear equations using properties of equality. The essential question: what is the first step in solving a complex proportion? Some linear equations may not look like linear equations upon first glance. A simple example that you should recognize is below. X over 5 equals 6 over 12. What do we call this kind of a problem, and how do we solve it? This kind of a problem is called a proportion. We solve it by multiplying both sides of the equation by 5. We can also solve it by multiplying each numerator with the other fraction's denominator. Here is the theorem that allows that. Given rational numbers a, b, c, and d, so that b is not equal to 0 and d is not equal to 0. So we write a over b is equal to c over d. We solve that by multiplying each numerator by the other fraction's denominator. So that will be a times d is equal to b times c. This is called the cross product, and we use the cross product to solve equations such as this. Now let's solve our equation. The equation was x over 5 equals 6 over 12. We'll write the cross product. So we have x times 12, which is 12x, and 5 times 6. Simplify the right side of the equation. 5 times 6 is 30. Next, divide by the coefficient. The value of x is equal to 30 over 12. We can simplify that and write it as 5 halves. The value of x equals 5 halves. In this lesson, our work will be similar, but the numerator and or the denominator of the fractions will contain more than one term. But we will solve the kinds of problems in the same way. We are going to skip example 1. We will do example 2. However, we're going to go to example 4 first on page 58. On page 58, example 4. Can this equation be solved? We can solve this equation because we can multiply each numerator with the other fraction's denominator, and then use the distributive property to begin to solve it. Using the cross product, I'm going to work on the left side of the page. For our cross product, we'll have 7 times 8 is equal to 1 times the quantity 3x plus 9. We simplify that. 7 times 8 is 56. 1 times the quantity 3x plus 9 is simply 3x plus 9. Pause the video and solve the equation. Resume the video when you are ready to check your work. I'm going to subtract 9 from both sides of the equation. That leaves me with 47 equals 3x. Divide by the coefficient 3. The value of x is equal to 47 thirds. Next, we'll go back to example 2. Example 2. Can we solve the following equation? Explain. We have a proportion, and we'll want to write the cross product. So we have 1/5 minus x times 3. 1/5 minus x. Remember to use parentheses when you have more than one term. Times 3 is equal to 7 times the quantity, 2x plus 9. 7 times the quantity, 2x plus 9. If you're confident in solving these kinds of equations, go ahead and pause the video and solve the equation. I'm going to distribute the 3 to both terms. 3 times 1/5 is 3/5. 3 times minus x is minus 3x. On the right side, 7 times 2x is 14x, and 7 times 9 is 63. Next, although there are many first steps I could take, I am going to add 3x to both sides of the equation as my first step. Simplifying, I now have 3/5 on the left, 17x plus 63 on the right. For my next step, I'm going to subtract 63 from both sides of the equation. That's going to give me my constants on the left and my terms with variables on the right. Simplifying 3/5 minus 63. I'll show the work on the side. 3/5 minus 63 over 1. I need a common denominator of 5, so I'm going to multiply this fraction by 5 over 5. This gives me 3/5 minus 63 times 5 is 315. 1 times 5 is 5. 3/5 minus 315/5 is equal to negative 312/5. The left side of my equation simplifies to negative 312/5. The right side simplifies to 17x. My next step, I will want to divide by the coefficient. Since I want to divide by 17, or the left side of the equation is a fraction, when you divide with a fraction, remember to multiply by the reciprocal. So instead of dividing by 17, I will multiply by 1/17. These are identical operations. Dividing by a whole number is the same as multiplying by its reciprocal. So I'm going to multiply both sides of the equation by 1 over 17. The left side of my equation simplifies to negative 312 over 85, because 17 times 5 is 85. The right side of my equation, a number times its reciprocal is 1, and 1 times x is x. The solution to the equation is negative 312/85. If you used your calculator, you may have gotten an answer of negative 3 and 57/85. And that would be the answer in simplest form as a mixed number, which is also correct. We're going to go ahead now. We've done example 4. We're going to do example 5 next. In the diagram below, now it's come to my attention that diagram may not be in your book. So if the diagram isn't in your book, pause the video and sketch the triangles. Label the sides accordingly. Pause the video while you do this. Using what you know about similar triangles, we can determine the value of x. So we have triangle ABC on the left and triangle A'B', on the right. Knowing that they are similar is important because we know that the corresponding sides will be in proportion. So we can write a proportion and solve for the value of x. Let's use a highlighter. We know that these two sides are the corresponding sides. So that will be one of our fractions. Then the other two sides that are corresponding are there, and that will be our other fraction. So I have x minus 2 over 9.5, and then x plus 2 over 12. And I know that these are equal. I'll write a cross product. 12 times the quantity, x minus 2, is equal to 9.5 times the quantity, x plus 2. Pause the video and solve for x. Distributing, I get 12x minus 24. Distributing on the right, 9.5x plus 19. To simplify, I'm going to add 24 to both sides of the equation. When I simplify, I am left with 12x on the left and 9.5x plus 43 on the right side. Next, I'm going to subtract 9x from both sides of the equation. This will give me my terms with variables on the left and my constants on the right. Simplifying, this is 9.5x. Let's go back and fix that. This is 9.5x. Simplifying, 12x minus 9.5x is 2.5x. Simplifying on the right, I am left with 43. Next, I will divide by the coefficient. Divide both sides of the equation by 2.5. The value of x is equal to 17.2. This is the solution to the equation. Next, use x to determine the length of AB and AC. AB is equal to x minus 2, so we have 17.2 minus 2. So the length of AB is equal to 15.2 centimeters. The length of AC. The length of AC is x plus 2, so that will be 17.2 plus 2. That gives us a total of 19.2 for the length of AC. Continue to the summary on page 61. In this lesson, we have learned some proportions are linear equations in disguise and are solved the same way we normally solve proportions, by writing the cross product and solving the equation. When multiplying a fraction with more than one term in the numerator or denominator by a number, put the expressions with more than one term in parentheses so that you remember to use the distributive property when transforming the equation. See the example below. When your numerator or denominator has more than one term, remember to write it using parentheses so that you remember to distribute. That concludes Lesson